Welcome back to the channel. Today, we're diving into some of the most mind-bending concepts in astrophysics, black holes, white holes, and how they challenge and expand our understanding of the universe. We'll be exploring these ideas through the lens of Carlo Rovelli's groundbreaking book, White Holes. If you've ever been fascinated by what might lie beyond a black hole's event horizon or wondered if the universe could be reborn in cycles, this video is for you. To begin, let's recap what we know about black holes. Black holes are regions in space where gravity is so intense that not even light can escape. They form when massive stars exhaust their fuel, collapse under their own gravity, and create a point of infinite density known as a singularity. This is where space and time become so warped that the laws of physics, as we know them, break down. Rovelli describes what happens as you approach the event horizon, the boundary of a black hole. For an outside observer, the closer you get to the event horizon, the slower your movement appears. Eventually, you seem to freeze at for example. This effect is because the immense gravitational pull slows down time, as seen from an outside perspective. But for someone actually falling into the black hole, time flows normally. This strange effect highlights how gravity, as Einstein described it in his theory of general relativity, warps not only space but time itself. Now, what happens once you cross the event horizon? According to Rovelli, this is where the story becomes truly fascinating. The traditional view has been that nothing can escape a black hole. Once it has crossed the event horizon, the gravitational forces become so powerful that even light, the fastest thing in the universe, is trapped. No matter how advanced your technology or powerful your rocket, there is no escaping the pull toward the center, or singularity, of the black hole. Space itself curves inward, leaving you in a continuous fall toward the core. But here's where Rovelli's ideas introduce a twist. He suggests that the singularity isn't the absolute endpoint we once thought it was. Instead, he proposes the concept of a Planck star. A Planck star is a theoretical quantum state where matter becomes so densely packed that it reaches the smallest possible scale, known as the Planck length. At this point, the collapse halts due to quantum gravitational effects. This means that the matter inside the black hole doesn't just vanish or stay trapped forever. Instead, these quantum properties create a sort of rebound effect, where the dense core of the black hole could potentially bounce back. Now, let's talk about white holes. What exactly are they? In simple terms, white holes are the theoretical opposites of black holes. While a black hole pulls everything in, a white hole expels matter and energy. Rovelli's theory posits that when the matter inside a black hole reaches the Planck star stage, it could be ejected through a white hole. This quantum bounce could mean that what falls into a black hole might eventually come out through a white hole, essentially reversing the process. From an external view, black holes and white holes are remarkably similar in their gravitational effects. They both exert pull on objects around them. But while a black hole is a point of no return, a white hole would be a point of no entry. It expels everything that comes close. This idea leads us to consider some massive implications. If Rovelli's theory holds true, it suggests that our universe could be part of a cyclical process of death and rebirth. The Big Bang, often considered the beginning of time and space, might not have been the absolute start. Instead, it could have been the result of a previous universe, collapsing into a black hole and then rebounding as a white hole. This concept is known as the Big Bounce. It proposes that the universe goes through continuous cycles of collapse and rebirth, a perpetual process that defies the traditional view of a universe expanding endlessly into a cold, dark end. Rovelli doesn't stop at cosmic speculation. He also delves into the philosophical implications of time and memory. One of the profound questions he asks is, why do we experience time moving only in one direction? Why can we remember the past but not the future? He connects this arrow of time to the processes happening in and around black holes and white holes. For instance, the time asymmetry observed in our daily lives might be related to the irreversible nature of processes occurring in these cosmic giants. This perspective opens up new ways of thinking about causality, choice, and how we perceive the flow of time. What makes Rovelli's work truly captivating is his approach to understanding the universe. He argues that we should not see the universe as an impersonal, detached entity, but rather as something we are intrinsically connected to. In White Holes, he suggests that the universe should be addressed as you, rather than it, highlighting a profound relationship between humans and the cosmos, just as a poet speaks to the moon, or as characters in Kipling's Jungle Book acknowledge their kinship with nature. Rovelli believes that recognizing this connection can deepen our understanding of reality. He asserts that we are not just observers. We are participants, sharing in the same cosmic fabric. This idea brings a sense of unity, showing that we are not separate from the universe, but integral to its ongoing narrative. So what does this mean for us as individuals? If the universe operates in cycles, with black holes leading to white holes, and new cosmic beginnings, it suggests that endings might not be as final as they seem. Life, like the universe, could be seen as part of a larger, continuous cycle. This perspective doesn't just apply to the stars, it reflects on our existence, our challenges, and our growth. Just as a black hole's collapse could lead to a white hole's emergence, our toughest moments could lead to transformation and new beginnings. Carlo Rovelli's White Holes challenges us to rethink our understanding of space, time, and existence itself. Black holes and white holes aren't just theoretical constructs. They are windows into the deeper nature of reality. They tell us that the universe may not be a place of isolated events, but a dynamic, interconnected web where every end signals a potential new star. Thanks for sticking with us through this cosmic journey. If you found this video insightful, don't forget to like, subscribe, and share it with others who might be fascinated by these ideas. And drop a comment below. Do you believe the universe could be cyclic? What do you think of the concept of black holes leading to white holes, and a never-ending loop of cosmic rebirth? Let's start a conversation.